Alrighty, Adam, you there?
Did you see the Twitter space I was in 5 minutes ago?
Were you actually in that Twitter space?
Yeah. I mean, only for long enough to hear someone making the claim that Bitcoin is going to 1 million and that
Makes sense.
She was planning, I don't understand this nomenclature, on drinking a cup full of no coiners' tears this evening.
Huh. Okay. Well, how did wait a minute, am I a no, is a no coiner the opposite of diamond hands? Is that what I am?
I don't even know what a diamond hands is.
Oh,
but I feel like I'm probably a no coiner and not a diamond hands if I had to guess.
I mean, if I had to pick between a no coiner and diamond hands, it feels like I'm more of a no coiner. But you know what? I don't even know. I don't even know. So Tom is here. Tom, we were just talking about your very enticing tweet about the Soviet Seymour Cray.
Oh yeah, he's a character.
Okay, so we got to start with it. So people want us to put the subject at the top. We are talking about got a book recommendation from George B on Twitter after we did our space, whatever it was, 8 weeks ago, about the Supermen, on the story of Seymour Cray, but of supercomputing more generally, which I just finished and loved. There's so much to talk about there. But before we talk about that, Tom, now I just want to hear about this guy. So tell me his story. How did you meet him?
Well, you probably know that Sun had several things going on in Russia after the wall came down. And Dave Ditzel was driving this relationship with Boris Babayan. And he was kind of people spoke of him reverentially because he got a lot of stuff done in spite of the fact that Russia really had no infrastructure to build state-of-the-art things. And I really only got to meet him for one little meeting. But
and what was the subject of the meeting? I mean, were you going to what was the...
I think it was very early on. Basically, hi, we're from Sun. Maybe we should do something together.
And what year is this?
This was 92.
Oh, man. This is only 3 years after, or two, maybe depending on when it was, in 92.
Yeah.
And it is, Tom, I find that it is hard to express to folks who post date. I mean, Adam, do you remember the wall coming down?
Sure, I remember the wall coming down, but I was a kid. But I remember it as a moment of significance. But I think it was 10.
Okay, so you may be a bit too young to appreciate how permanent the wall felt when it was up. It felt like, it just felt like this was never going to change. I don't know, Tom. That's how I felt.
Oh yeah, and so when I did the trip in 92, people were still in this kind of state of euphoria about things are open and we're going to be normal and have great relationships and blah blah blah. And it was a really, really fun trip to Moscow.
That must have been unbelievable.
Yeah, seriously.
With much vodka.
Okay, is this in the winter, the summer? When is this?
Summer, beautiful summer. Oh my God. Mostly we were talking to this other group headed by Sasha Galitsky, who has since become an international venture capitalist. And in fact, the guy I worked closely with at Sun, Jeff Baer, who started up this relationship with Sasha's group, now the two of them are venture capitalists, and you may know them at whatever that firm is.
That one, the one that passed on us. We're gonna have to be a lot more specific.
They're rooting from the side.
Exactly.
Yeah, I'm blanking on the name of the firm, but they specialized in east-west deals until things got really bad with the relationships, and so now they're a bit more normal.
And so, Tom, what did Russian, and then before that, Soviet computers look like, or Soviet computers as they emerged out of the Soviet Union look like when you visited?
Well, they mostly cloned Western computers. So they cloned the IBM 360, they cloned the PDP-11s and PDP-8s.
This is like the Concordsky of PDP-11s.
Yeah, but the whole manufacturing infrastructure was so weak Now, the best story I heard, though, is they cloned the Sun 3. And but the trouble is they couldn't get the processors, and they were building their own processors, and every processor was broken. So in fact, they ended up, when it worked, you had a lot of custom kernel hacks per processor, not per type of processor, per processor. And so it was just pathetic.
Wow, that's pretty incredible.
So it's like what the UNIVAC 1 guys were doing back in the 50s. Just total lack of manufacturing prowess.
So each one off the line would have its own sort of customized collection of stuff?
Yeah, you do whatever hack it took to kind of make it work. And I think it was coming from the ZIL limousine factory. That was the other key.
That's incredible.
So,
And so did they have any real de novo systems of their own, or was it all just clones?
Yeah, well, Boris Babian was known for the Elbrus family. So those are pretty architecturally interesting. Wikipedia talks a little bit about them, but, Superscalar way before other people were doing that. But, again, they just kind of just barely worked, and at not very impressive clock speeds.
That's crazy.
In an act of supreme cruelty. In an act of supreme cruelty, I'm having to talk with myself. In an act of supreme cruelty, Tom, the Twitter app decided to exhaust all memory as you were telling the Sun 3 clone story. I'm gonna have to pick that up on the recording, but it's this whole. Adam, wouldn't you watch a movie about Tom going to Moscow in 1992? I just feel like there's so much there.
I would make that movie. Are you kidding? I would write that screenplay if I could. That'd be so much fun.
Oh man, it just feels like that. Tom, it must have felt that way even at the time, to realize that that this probably felt historic, I imagine. Is Tom there?
Oh dear.
Oh no. This is, Twitter Spaces, you were doing better, and now, oh, there's Tom, maybe. I think Tom got bounced out. Oh man. All right, we're gonna. There's Tom. Tom, you back?
Hi there. Testing.
Yeah, you're here. Yeah.
Good. Yeah. So anyway, I actually wasn't one of the main people going to Moscow, but I was on my way to Geneva, and so I tagged along. And the Geneva story is a whole nother story, but that was fun too.
So, how did you end up meeting Boris? How did that? What was the context for that meeting?
I don't remember. Dave Ditzel somehow knew about him and had started a relationship. And then eventually Sun bought his whole group, and they worked for Sun for like 12 years.
Is this the St. Petersburg group? Where were they based? Okay.
They were based in Moscow. So there were two Moscow groups.
Okay.
There was Boris's group, and there was Sasha's group. Sasha's group worked on VPN and networking stuff. And he hit before the wall fell. Sasha was working on satellite networking technology, which was pretty amazing. But then the St. Petersburg group was after this trip. Somebody found them, and then that's where a lot of cool people came from.
Yeah, certainly there were we had some extremely bright colleagues out of the Sun offices in Russia, certainly. Well, that must have been amazing, and I would love to know more about the kind of the computers that he built. And so, Tom, you said that you never met Seymour Cray.
No.
I remember him dying vividly because I was with some Sun engineers when he died. I just remember John Johnson, one of our colleagues, proposing a nanosecond of silence to memorialize Seymour Cray, which at the time I remember. I don't know. Now I can't figure out if that's like if that's appropriate or not. I don't know, but you know, it was what it was. But Tom, have you read this book, The Superman?
Yeah, in fact, I just reread it because I saw it was coming.
This book is mesmerizing to me. I felt like there was a lot that so Adam, a couple of things that I felt I came away from the book with. So one, something that we don't really appreciate about Moore's law is how it's not just doing more with less. It's not just about greater transistor density. It's not just about greater transistors per dollar. It's also about much more power per watt, much more like many more transistors per watt, much more compute power per watt, much more efficiency. And Tom, I can't believe how power hungry these machines were. So Adam, they had a board, like a daughter board in I think the 6600, the CDC 6600. That was 3 kW. Just like
a board.
Wow.
Yeah.
And it's like, oh no, it's like, well, how do you even cool that? Like, oh well, no problem. We're just going to use we'll use liquid cooling. You're like, okay. And so on the Cray 2, they are spraying this thing with Freon because water cooling is insufficient. It's just
yeah. Well, back at Princeton, yeah, we had the 36091. Which this book talks about never working, but it worked fine. But it was water cooled, and one day the IBM guy forgot to turn on the water when booting the machine, and they had a core meltdown.
Okay, so that's interesting because this book does talk about the 360 Model 90 and it ended up being the subject of a lawsuit between CDC and IBM because they were accusing that machine of being entirely vaporware, but you had one.
Well, it was way pre-announced. They announced the Model 90, and then later on changed the announcement to 91 and 92, and then 92 never shipped, but eventually a 95 shipped. You know, but it was a killer machine, but it wasn't quite the 6600.
And so what was the difference between, I just don't know the 360 line well enough to know, because I know like the 85 was the top of the line when they originally announced the 360, right? I mean, that was the machine on...
No, I think 85 wasn't in the original announcement.
Oh, was it not? Okay. The 85 is famous to me because that is the first machine to have caches.
Right.
And I just love, I know I've retold this story before, but I just love it so much about the fact that when they developed the cache, they were describing the approach they took for the IBM Systems Journal. And they had not, as far as they were concerned, they were buffering memory. So we're going to call this a muffer as a memory buffer. And the editor of the Systems Journal was like, wow, this seems like a really important concept, but like, I don't know, muffer? Like, can we do better than muffer? And that's like brainstorming with the engineers. He came up with the idea of like, it sounds like you're kind of like leaving something and then coming back later to it, like a cache, like a cache. Like, all right, well, let's call it a cache.
Yeah.
Much better name. But so the 90 is obviously, because I don't, was the 85 water cooled, or was it just the 91, 92, 95?
It probably was. That one of the key differentiation of the Amdahl machines in the 70s was that they were air cooled instead of water cooled. So I think most of the higher end IBM stuff was water cooled.
So Brian, in addition to the 3 kW, can you give us some other specs? Like what was a supercomputer?
Okay, so the one that so there are a couple of interesting things. One, and you know, I don't know how much of the book to take as apocryphal, especially given what Tom is saying. But the one thing that's interesting about Cray is it actually reminds me so much of Clarence Kelly Johnson at Skunkworks, about he's deliberately not trying to be on the bleeding edge of everything. So in particular, he did not really believe in the microprocessor, which I didn't really realize that there were microprocessor malcontents. But he felt that he was going to get better performance by using effectively discrete components than using a microprocessor, which is probably true at the time, I guess. I mean, he was certainly getting ridiculous clock speeds that were far greater than any microprocessor.
Is that just because the process wasn't there yet?
That's my read on it, Tom. I don't know if you got. I mean, you were definitely on the scene then. I mean, what was the rationale for? Was Amdahl? Amdahl was also not using a microprocessor, right?
No. Yeah, the 70s was way too early for serious microprocessors. I'd be surprised if there was any real supercomputing done on them before 1985.
On micro. So there you go. Yeah. So Cray is so these are all with effectively discrete components. So he is all about getting better performance with shorter path length. And so that means he's jamming more and more components into smaller and smaller area. So a lot of what they're doing is refrigeration. I mean, that's like he at both at ERA and then CDC and then Cray Computer. Because another big theme I have to say is these folks getting funding at one company and then that company becoming kind of ossified with management and in very familiar themes, then rebelling and going to a new company. And so Cray, they all leave ERA together and they form CDC. They form CDC by like getting money from like friends and family in the 60s. They're basically like selling the company at Tupperware parties was my read of that. Tom, I don't know if you had to. Which was, and they were able to raise money to start Control Data, obviously a very important company. And then Seymour Cray is at CDC. He does, so one thing I did not know, the CDC 1604, which I think Tom, I showed you my beloved manual for the CDC 1604. That number, the actual number for that, comes from the ERA 1103, which they all worked on at ERA, added to their street address, which was 501 Park in Minneapolis. Which I felt like, it feels like some things don't change. Adam, doesn't that feel like something?
That totally wonderful. And you're right. Like they're out to lunch and someone says it and they're like, dude, we have to. Obviously, we have to.
Didn't we have like a port that was 450 for 450 mission? I feel like we used 450 mission in something that we did.
We had a Sentinel value in the Fishworks product, which had to do with the day that we all sort of dropped our books simultaneously and told management that we were leaving to go do this other thing.
That was delicious, by the way. That was like, we all five of us separately told our management that we were leaving at the same moment, like Godfather style, which I think we even called it Godfather style at the time, if I'm remembering correctly.
That's right. Or we named it the Red Wedding, and then
right, 15 years later. That's right, 15 years later. Well, but this is a very common theme because this basically happens again and again and again for supercomputing in particular. And so he leaves. CDC, he decides, has lost its way and leaves to go start Cray Research. Then CDC has this. I would think, man, the thing about supercomputing, they are doing incredible. It's like, I swear, Adam, if you think that we at Oxide are nuts, the history of supercomputing will assure you that there are people much crazier than we are. I mean, like literally, it's like Oxide, but a factor of 10 in every conceivable dimension. They raise a factor of 10 more money with a factor of 10 more risk. And when these companies end, they fly into the mountain. Like every single one of them.
That's sort of by design and by definition, though, right? I mean, if you are building an Oxide rack, you are by definition not building a supercomputer. Right? Like, supercomputing is just defined by the fact that it's an order of magnitude past what anyone would consider reasonable.
That's right. I think, no, that's a good point.
And like, even on the 3 kW number, that's honestly not that extreme, right? Like, I mean, if you think about people like Cerebras today, that wafer chip thing is 23 kW.
Yes, which is crazy. I mean, and they had to solve many unsolved problems in order to be able to. Dealing with the thermals there has been a huge challenge to the point where, and I mean, because we share a board member with Cerebras, I get to answer a lot of thermal questions. I have to reassure Pierre that we are thermally nowhere near as adventurous as Cerebras is. But and I mean, I think you're right, man. There's something tautological there that like it's a supercomputer, so of course they are going for 10x. The thing that is surprising to me is that these companies, when they fail, right into the mountainside. Like people learn that they fail because they go to work and like they've been locked out of work. Like the badges don't work, and that I feel is a bit atypical.
Why is that so surprising though? Right? I mean, like if you build a mediocre oxide rack, you will sell a mediocre number of them. If you build a supercomputer that is not the superiest supercomputer there is, no one cares because like that's old news.
Yeah, you're right. You're right.
Yeah, I mean,
right?
if all you're selling is the fact that you're number one, and you're not number one anymore, you're in big trouble.
No, you're right. This makes total sense. It just is brutal because you keep reading about it over and over and over and over again. And so and I remember this happened, and Adam, I was asking you earlier if you remember my ETA systems phase. So ETA systems was a skunkworks effectively inside a CDC to do a new supercomputer. And they really interesting stuff. Do you remember ETA, Tom? I don't know if you had any overlap or.
I didn't know much at the time, but I've read a fair amount about it.
And I think I think actually Larry McVoy worked at ETA for like a summer. But the ETA is making a supercomputer, and just like Tom, what you and Matt are saying, they're vying for number one, and they're not getting there. And so these guys all come to work, and like they've been locked out of work. And the doors are locked. Buses come. They pick them all up. They go to a theater in St. Paul, and they think that they are going to hear that the company's been acquired. But CDC gets on the stage and is like, "You're all out of a job, basically. Like there is no ETA." And even though and I just remember when I reading about this and just being mesmerized by it. It feels so graphic, I mean, Adam, we've lived charmed lives in that I have never lost my job this way, and it feels like it would be really upsetting.
Oh, for like the company to run out of money?
To run out of money and just like suddenly, it's not like, okay, yeah, things are getting worse. I mean, like, okay, yeah, we know we're struggling, but we're still kind of collectively believing, and then like, bullet in the brain, it's all over.
Well, I think that's part of like
how about the story? How about the story about the ERA guys who one day they wake up and the company's been sold? It's like, wait, I thought I was running the company.
Right. Yeah, exactly. Reading about it in the paper. But so ETA, and I actually remember, and so Adam, I wanted to like, in part because I was having to go out to Minneapolis Berkshire was going to the University of Minnesota for some reason, and I was really interested to learn as much as possible about this event, and so I talked to a couple of people that were there, and they told me that like it was even like crazier than it sounds, and people didn't really see it coming. This one guy described for me going over to a colleague's house, and that formerly ex-colleague, and they are sending faxing resumes out to Pyramid Computer, and they're faxing resumes out, and then Pyramid is faxing back a response on every resume, and they're all hired. So they're basically like they're all huddled together in this house, all getting jobs in California, and then everybody's packing up and leaving for California.
That's crazy.
Isn't that crazy?
Yeah.
I felt like, is this like John Steinbeck writing a novel about computing or something? It just felt like it's like this very, and because people were giving up on effectively Minnesota as at the same time as they were leaving ETA or had been axed from ETA. But so this happens again and again. So Adam, you're asking about some of these extremes. So Steve Chen is this guy at Cray. So another thing about Seymour Cray, man, that guy does not like, what's the right word? He builds something and then immediately wants to go on to the next thing. So he does not want to see things through. I really like to see things all the way like into a customer's hands. I think, Adam, you and I have that same disposition, certainly, of wanting to see it from initial idea all the way to running in production. And I want to know, like, when it falls down along the way, I want to know why, and I want to pick it back up. And Seymour Cray does not have this interest.
Sounds a lot simpler.
Yeah, it is kind of simpler to me. It's like, all right, so he just like goes on to the next thing. So he is like, the Cray 1 is effectively not even done, and he's already decided that like, no, like we did it all wrong there. I'm going to go do the one true machine in the Cray 2. And he's not interested at all in the Cray 1, and in particular, he's got zero interest in software compatibility between it's like just software compatibility, not something he cares about at all.
I mean, software compatibility is also not really a cultural value in supercomputing.
Well,
like,
yes.
You will build the software from scratch, of course, obviously. Right? Like.
Well, but then Cray would have died a lot sooner if they hadn't done the Cray XMP.
Well, that's it. And so the Cray XMP was led by unclear. Steve Chen, according to the book anyway, very clearly willing to take credit for and totally unclear how much credit is due or not due. But Steve Chen becomes the face of the Cray XMP, and then later the YMP, which is, Adam, this is basically the Cray 1, kind of continuing the Cray 1, maintaining binary compatibility with the Cray 1 in particular. While Cray goes off to the Cray 2, he then leaves Cray and goes ultimately separates into what becomes Cray Computer as opposed to Cray Research. Steve Chen then leaves Cray, and this is like, I'm leading up to this example of like just nuttiness. So he leaves Cray. IBM decides to fund Steve Chen's new supercomputer startup. This is in 1988. IBM puts $150 million into the company.
That's a lot of money. I mean, now and then.
Like,
jeez.
That would be a ton of money now. It's like that is. I mean, that'd be like raising a $600 million seed now. You know,
it might be worth keeping in mind who buy these machines, right? So, like maybe it's more useful to think of supercomputing kind of like aerospace, right? It's like the government is going to pay whatever it needs to build the machine that's going to let it simulate, material degradation in nuclear weapons. That's what these machines are built for. So maybe it's not so surprising that these things were so well funded.
Yeah, that's what always bothered me about the HPC world is it's not actual economics.
It's not actual economics. That's right.
Yeah.
It's not actual economics, and it doesn't force rational economic decisions. And so the Steve Chen startup, this outlandish $150 million in. So Adam, they make a 78 layer board, which is
a lot of layers. How thick was that?
Great question. So definitely, folks at Oxide were kind of doing the math on that, and Rick is like, that's like at least like a half an inch thick.
It's like plywood at this point.
It's plywood, and like there are lots of. I mean, if you got to back drill that thing, like it's just nutty. So and they.
Hang on, how many layers did you say again?
Exactly 78.
Maybe a quarter of an inch.
Sure. I mean, it's. I mean, we have got we've got a 28 and a 16 layer board, and both those things are considered to be like big boards. 78 is a very large number.
I mean, the fact that we're using like English, woodworking measurements, like quarter inch, half inch.
That's right, exactly.
Rather than like millimeters, explains how big it is.
It is a board that is 4 fathoms deep. It is.
You're going to need a bigger ruler.
Maybe it has something to do with signal integrity or something. Like maybe every second layer is like a ground plane or something nuts like that.
For sure. I mean, I'm sure that there are like somewhat rational reasons, but it's also happening at a time.
What year are they building this in?
That started in 1988. Which, I mean, by the way, like that's not right about the vision for the future. I mean, that's the other thing. It's like these guys actually were all kind of like, I mean, don't want to put it too sharp a point on it, but they were kind of wrong. Right, and it was pretty clear by 1988 that was probably not the trajectory certainly by the mid 90s, it was crystal clear, and this was a dead end, I would say.
So aren't all supercomputers hot rods? I mean, necessarily hot rods, but hot rods in the sense of like they're one-offs and they're performance art, and they are never meant to be a platform or like the next version is supposed to be starting from scratch anyway. Isn't that true throughout the history of supercomputing?
I mean, there are small batch things, right? Like IBM Blue Jeans. There's probably 100 of those in the world.
So I worked on a Sun constellation, which was pretty much commodity x86 hardware with a third-party interconnect. There's sort of a difference between grand challenge supercomputing, where you are aiming for a scalability and a problem type that addresses some very big patrons' needs, versus service bureau supercomputing, which is what nci.org.au did for a long time and still does it, although I stopped being associated with them. And so, yeah, the Sun constellation system that we had, which was 1,500 processors, it was a reasonably big machine. It was biggest in Australia, but it wasn't by any means a grand challenge machine.
Yeah, it was commodity CPUs strung together, and it's like ultimately that's a better use of kind of humanity. It's like
one of the things about that was that it existed within a software framework by then of distributed style message passing support, rather than write screaming vectorized loops and maybe split them up across a few CPUs which all had access to the same memory, which was interleaved umpty bazillion times, which was the old CDC 7600 and later 205, the 512-way interleaved memories, and I think, well, anyway, 512-bit memories, but anyway, crazy high bandwidth memories, but shared memories between a bunch of CPUs. When the software support for message passing actually got to a point where you could actually scale out around about clusters, I think that was that was when I think even Seymour Cray had agreed shortly before his passing that he had been sort of hit over the head by microprocessors enough to kind of accept that they had a place.
Yeah, microprocessors had a place, and so in particular, Adam, he goes down the gallium arsenide route. That we're going to make silicon, we're going to be faster switching than silicon can offer. So that was kind of his angle, especially at Cray Computer, working on the Cray 3 and Cray 4, a company that also ends with people being locked out of their workplace. And it's like the common theme across all of these. So, but Adam, your question about like, are these kind of one-offs? I mean, I would argue that supercomputing today is in the GPGPU. That is the kind of special purpose high performance computing today. It happens to have a much, much broader commercial application than testing nuclear weapons, which is effectively what the commercial application was for supercomputing. It was a little bit broader than that. And so now I think between the uses we see with GPGPU and DL and ML, I mean, there's a broader use of it. So I would say all of that kind of zeitgeist has gone into the GPGPUs, but I would love to get the perspectives of others for sure, who are going to be better versed on this than I.
Hey, I want to mention, put in a plug for Shaheen Khan, who I see listening here, but he has this whole Dead Architecture Society meeting every year.
Oh, nice.
Which should be coming up. Shaheen, can you talk?
Yeah, I invited Shaheen to speak. So yeah, if he's around, yeah, they'll click. Hey Shaheen, how are you?
Hey, thanks for having me up here. I'm really enjoying this. And I was just gonna, since I have the microphone, it's also the interconnect. I think that the GPGPU is really where the action is in terms of performance, but it's also highlighting the importance of the fabric. So if you look at the latest, greatest, it's like the Cray, HPE now, Shasta, Slingshot interconnect, or really the NVIDIA Mellanox interconnect. And in fact, the system that was spoken of earlier, the one in Australia, that I believe was a Mellanox interconnect too, or was it the big fat switch that Bechtolsheim built?
Right.
It was in fact not the humongous. The humongous switch was the copper 120 gigabit cables. This was the one that was based on, I forget how many ports. I'm going to say 576, but I don't remember if I've multiplied that out right. But it was sort of 10-inch rack unit switches, and we had 4 of those in the core, I believe, and they were all running CXP 120 gigabit trunks out to edge optical CXP out to the nodes, out to the edge switches, which were basically the Constellation. The rack was the blade chassis, and then in the Constellation chassis there were 4 slots for Mellanox switch fabric switches, like 2 switch chips per
crazy machine.
For people
it was a good machine. It could put out 35 kilowatts peak per rack, so cooling was a real issue, and I've got some stories about that. Yeah, not kind of grand challenge stuff, but the previous machine, the Altix B3700 that they had, nearly died as a result of a really interesting failure mode after a thunderstorm supercell, which knocked out the UPS for the management part of the machine, but not the raw power for the interconnect. There was a raw power for the nodes. And but it had also knocked out the water chill loop, because the floor was flooded and the sensors had been installed on the basis that they thought, well, the reason the floor will be flooded is because the water chill loop is leaking, and so it shut down the pumps. So they had no cooling and no way for the management stuff, which was turned off, to turn off any of the nodes, which didn't actually have that as a separate monitoring thing devolved onto each node. So it was just sheer luck that the main admin lived near enough by that after the supercell, he kind of got his Subaru and scooted through huge amounts of hail on the roads and turned off every single rack by hand.
Wow.
That's a fantastic story. I have been watching, because I have a login on this machine. I've had a login for the last 2 years. I haven't really been using it, but I've been getting all the maintenance notifications. And I have to say that lately, basically the failure mode of these big machines is that the Luster file system craps itself, and then a consultant comes out and kind of like looks at it for 4 days and then gets it back going again. But I think that machine currently, the current machine at the NCI, and just about every sort of run-in-the-mill machine these days is just InfiniBand, and that's Mellanox, right? So Mellanox EDR or whatever. But there are some startups doing some new stuff in interconnects. I'd be interested in hearing other people's takes on like what Rocketport are doing, and what is it? Infabrica is the other one.
Yeah, and Shane, I think you made this. I think, assuming this is what you're tagging into, Shane, you're making a very good point about the interconnect kind of becoming everything effectively. That the supercomputing kind of switches sometime in the 80s to 90s, where it is all about connecting compute elements quickly with low latency and high bandwidth, rather than making the single fastest compute element.
Well, when you
totally
when you go to the supercomputer show, right? People talk about the Cray era, which was a solid 40 years from 1950 to 1990. It was all single processor performance. But then after that, it's parallel, and then the interconnect dominates.
Yeah, I mean, the Cray era, quote unquote, kind of ends at the memory wall. And I mean, the guy sees ahead sort of to that, to the point where he starts innovating on things like DDR memory, because you just need better signal integrity for it.
Yeah.
But at the same time, even a grand challenge style supercomputer only gets to innovate on maybe two, maybe 3 dimensions, right? You're not going to have a whole new processor and interconnect and silicon process of, good grief, gallium arsenide.
Or you can't do all that.
Even with $1 billion seed budget, you can't, with good conscience, innovate on all those different axes at the same time and think this isn't just going to end catastrophically.
Well, I say you can do all that. It's just going to find yourself walked out of work one morning, and everyone is going to be waiting around for a bus to come pick you up. So yeah, I mean, you definitely. I agree with you, Matt. That you. Sorry, Tom.
These days, not even the governments can afford to do the.
That's right. Yes, I mean and that's what makes these numbers seem otherworldly, because it's just not something that would ever get funding now from anybody, a government, certainly not from the private sector. But Shaheen, sorry, I think you were saying something about the importance of the interconnect.
Yeah, I was saying that I actually liken it to a glue, and because it is the glue, and I say that the viscosity of the glue is the issue, and if you have like a really watery glue, that's Ethernet, and if you have like cement, that's SMP, and you got everything in between. And ultimately you want address coherency as well as bandwidth as well as latency, but you have to kind of clear one hurdle before you get to the next one. And right now it's all, as was said, all distributed memory, message passing, and that was made to work. And I think Seymour didn't think that was going to work. He was really relying on the programming environment to be an issue, and I think that's why he kept. Now, to their credit, they did do parallel systems, so they had like, I think the C90 was like 16 CPUs, and by the way, that was a 53-layer board, if I remember correctly, and that was in production. Yeah, and they also had like some levels of 3D stacking that is now like what AMD announced today. They had like equivalent of that between boards. There was this thing called, zero insertion force, but then they also had these like cloth-looking things they would put in between boards. So when the boards would be inserted and then they would be pressed on top of each other, signals would go vertically up and down. It was like a crazy system, but it was production, and it was 16 CPUs at the time with lots of memory.
And
one of the things.
Sorry, go ahead, Courtney.
So one of the things I wanted to kind of point out there, when talking about like the larger ecosystem problem that Cray faced, especially, they were kind of, while Seymour Cray was very advanced in trying to drive hardware technology innovations, right? The software side was a huge problem for them as times changed through the 70s and 80s. Like, one of the things you had, in the 70s, you'd sell to a national lab or to, a defense program, and they'd help you develop your compilers. They would write their own OS, and you tell the machine, and then you get, your next generation didn't have to be compatible or whatever. By the late 80s, that was becoming less acceptable, right? You had to have a good compiler suite. Yeah. You expected to have, an OS that would run on several generations of machines.
Yeah, even in the mid 80s, people were starting to demand Unix. That's part of the ETA story, is how they had shift gears to support Unix.
And right. Even today,
and then by 93, you had the end of the Cold War, or 91 rather. You had the end of the Cold War, and all of a sudden this funding dries up, right? And even Cray not Seymour Cray, but Cray Computer saw the need to do MPP stuff, and came out with the T3D and the T3E, which were very massively parallel machines in the kind of way that you might recognize today, right? Using commodity alpha CPU.
Well, yeah, and Courtney, you're tacking into a very kind of question that I actually would love to ask Shaheen, because Simeon, you had this question about what was the influence of Cray on Sun. And Courtney, you're talking about these machines and where they're using, more commodity silicon. Of course, the logical extreme of that was the Cray Business Systems Division, BSD, making the C6400 out of Spark CPUs. And Shaheen, were you at Sun when that acquisition went down, when we bought Cray BSD?
Yeah, I was. So before that happened, Floating Point Systems, which was actually one of the systems that the Bulgarians had cloned, and I think Bulgaria was like one of the hotbeds of technology for the Eastern Bloc. So Floating Point Systems was building attached processors, accelerators essentially, and then they had graduated to build Unix systems with a vector attachment. And the CPU was based on an NCR chip in the old days, and it was like so they decided that they needed a standard CPU and standard OS. So they cut a deal with Sun to use Spark. And that was the beginning of it. And it was like it was a FPS Model 500 and then Model 500EX.
And then FPS bought Cray, is that right?
And then, no, Cray bought FPS.
Bought FPS, okay.
And so that's where Cray BSD comes from.
That is correct, yes.
Okay. So and then
Cray,
yeah.
And then SGI bought Cray and didn't want any Spark stuff.
And then SGI bought Cray, and of course, Daryl Ram, who I think I saw him in the audience. He was on the SGI side of it, and the history of it is really quite funny. And well, it is what it is, but it is also funny. And because SGI really had no use for this system, and they should have just killed it, but they didn't for whatever reason, despite advice to the contrary. And they decided that they were so confident of the SGI origin that was about to come out right around then, and it was a really nice CC NUMA system, and that and they sold it to Sun. So when I was at Cray, we were basically told that SGI is buying the company, and we have no use for you. So go sell your division to somebody. And we started shopping it around, and we did a whole prospectus. And I remember in our prospectus, we said that whoever buys us, we think we can sell like 150 systems in our first year. And we sold like 200 systems in the first quarter at Sun.
Yes.
It was like incredible.
Okay, and so Shaheen, the purchase price of Cray BSD by Sun.
Well, I think rumors are varying between $15 million and $19 million, and we had a whole inventory. And the idea was that if you sell the inventory, then you owe me another 10. And of course, the whole thing was done like within 30 days. It was like no problem, right?
So, and I had heard the purchase price was not something that was well known inside of Sun. I had heard actually numbers even south of that it was below 10. But apparently, it was definitely, this is the best acquisition in the history of the industry without question. It is certainly purchased for less than 25, right, Shaheen? And
I think it was certainly less than 30. I think McNeely called it, or somebody called it, the best acquisition since Babe Ruth.
Hi, Shaheen. Thanks for mentioning me. So I'm Daryl Ram. I was on the SGI side. There was a faction of SGI people that were violently opposed to this sale. And there was a faction of people that wanted just to sell it. And the wanting to sell CBS seemed to really come from within inside Cray. So the Cray supercomputer guys arguably had wanted to, didn't really see a future with the business systems and wanted to get rid of it. I found out about by literally walking into the office one morning and finding my boss there and my general manager I work for and saying, what's going on? And he's like, well, they want to sell CBS. He'd already been over to the CEO and president and pounding on the table trying to undo the deal, and he failed. And I basically accused him of failing and had an argument with him. And he said, well, you go and do better then. And I looked, okay, well, fuck it, I will. So I walked across to the corporate headquarters, met with our lawyer and with the president, and I just on the spur of the moment made up had a list of customers that we knew that where Sun was running out of power on their high-end servers, and we were doing an incredible job with competing with the Challenger line. And I already, just by a couple of accounts, already had like $10 or $20 million of business, and said, why would you give this to Sun? And I think the response to me was, what do you want us to do? Just buy it and bury the Spark stuff? I said, absolutely.
That's exactly what I want you to do. I'll give you a shovel.
Absolutely. And in parallel with that, big secret, I was trying to hire Shaheen. We were trying to hire Shaheen personally, and we just did not want this deal to happen. It was the stupidest deal ever, and it just irritates me when everybody says SGI, made a bad decision. There was a group of people inside SGI that fought like hell to stop it, but we failed.
It wasn't the stupidest deal ever. It was the best deal ever. What are you talking about? It was
then there was SGI and Windows NT.
Well, yeah, exactly. Come on, that's not right to do. Poor Daryl. I mean,
that's unfair to bring that up.
That is unfair. Exactly. We said no one is to mention Bob Bishop.
But at that point in time, Sun had done so well with these product lines, but it was running out of steam at the high end.
Yeah.
Silicon Graphics had accidentally fallen on this incredible product, the Challenge line, which was just killing it at the high end, and to give away it made no sense at all. It was just insane. So
that product on the kind of the Sun side of that, that bought for, again, south of 30, that did $1.2 billion of revenue in its first year, I believe, Shaheen.
It was. I think the story there was that I remember we launched the product like January 17th, and then it's like April 5th or something, and Sun is getting ready for their quarterly report, the financial analyst report. And and we had a meeting among the marketing team, and we decided that this was our tagline. So I call up Clark Masters, my boss, and I say 100 days, 100 systems, $100 million. And it was like such an irresistible tagline that I think Ed used it on the financial thing. And then from then on, it was like the only product where the revenue was disclosed. And then, of course, it just went from strength to strength.
It was, and when that product was the right product at the right time. It was the right bet in exactly the right way at exactly the right time. It's hitting the internet. Internet is going supernova. People are unable. This is long before distributed systems are really a thing. And
so what year was that? 97?
That's 97.
That was 97.
Yeah,
the other big thing, Brian, was SAP R3.
Absolutely.
Everybody was moving SAP R3, and it was a shared memory hub.
Yeah, absolutely. So Adam, we're within nanometers here of the origin story of DTrace, because this is me working on my birthday in December 3rd, 1997. I basically worked 24 hours that day because we had this SAP benchmark that we were doing for GM.
Right. Yes.
Do you remember this?
Yes, I do.
So this is itself is an incredible story. So we've got this thing has, and I am in the poor software group, and we of course we've got maybe one E10K that's going to maybe make its way to us at some point. I have basically never seen one of these machines. And there are 5 associated with this benchmark. 5 racked out E10Ks, 64 processors, 64 gigs of RAM.
How much money is that?
That is so much money that finance was in on the calls because they needed to know when the machines could be released for revenue recognition. So this is like you are sitting on the quarterly numbers, basically, for a multi-billion-dollar company running a benchmark. And Shaheen, I don't know, I'm sure you were aware of this going on when it was happening. It was definitely a big deal when it was happening.
Yeah. Part of the thing is coming from Cray was that it was such a techie company that customer benchmarking and industry standard benchmarking reported into marketing.
Right.
Because everybody was geeky enough to handle it. So Carlisle's group was heavily involved with the SAP benchmark.
Well, and it was great for me.
That was my team.
Yeah, right.
And it was awesome.
They were awesome. So I was working with all those engineers. So we were basically working hand in glove. And so I'm meeting them for the first time and really enjoying it. And Shaheen, I don't know if you recall these details, but this thing is running this benchmark, and it is just clearly on the way to beating every record out there. This thing is going to set this world record at GM for this SAP benchmark. And then the great sadness would happen. And there would be like 3 minutes of profound sadness where the machine is miserable and it is entirely unclear what's happening.
Oh, I totally remember that.
Okay. Well,
I do.
And so we are, and this is running on Solaris 2.6, and so the only tool that I've got is Lockstat, which is actually hugely valuable. And so I'm writing custom kernel modules to instrument the kernel, and that machine would take 2 hours to boot. And when I would fuck up, which I definitely did over that, the week that we worked on, and all of a sudden, the guy who was working with the Cray is like, is there something wrong with the machine? You're like, oh fuck, the machine just bounced, and now I've got like 2 hours to think about what I've done wrong. But that with Shaheen, it was actually after. So the root cause of that, I was convinced that the root cause of that was we knew that the network stack was going insane. And I'm like, there is a software bug in here. There's a bug in the operating system, obviously. I mean, like the operating system is suddenly chasing itself. And there was a bug in the operating system to a degree in that there was like an order of n cubed algorithm. But what the actual problem was that for some reason, the operating system had been turned into a router. And what was actually happening is in the lab in which they were doing the test, there was another Cisco router that would bounce that had its own firmware bug. This thing would basically reset. And when it reset, the E10K was misconfigured to act as a router. So it would volunteer to be like, oh, instead of being the world's fastest SAP machine, I could be the world's slowest router.
This is
That's
your
it. Blame it on the
liquid-cooled.
networking guys.
This is your liquid-cooled supercomputer
Right, yeah,
volunteering to be your Linksys
That's
router.
exactly right. That's exactly right. Like, I know how to route packets. It's like, no, we really, okay, great. I'm glad you know how to route packets. No, I can route packets very poorly. Please get out of my way. Because of course the operating system is like not, and that this is where you're getting into like all of these suboptimalities of the operating system where it's like not really designed to be a router. And so Shaheen, I don't know, that was the root cause of that. And to me, that whole experience was really chilling because it was like, I had assumed that this was like going to be an OS bug. And actually in the end, it was a misconfigured system. And you begin to realize that, like, wait a minute, if this is a misconfigured system, and then we took 2 weeks to debug that. And Shaheen, you remember that was literally around the clock to make sure,
Absolutely.
to make sure that
yeah.
somebody was working on that problem all the time because those machines were so valuable. You could not let them sit idle. And I remember thinking, like, no, like you could not have more resources on a problem than this one had. And boy, where does that leave the poor, like, just person that can't summon these incredible resources for 2 weeks? And you realize, like, we have got to have a better way of being able to answer these questions about the system. So there you go, Shaheen. That's the origin story of DTrace.
That's wonderful. That's wonderful.
Can I also just ask can I just ask 2 hour boot time?
Yeah, that's no joke. Why is that? Yeah,
we didn't have certain things at the time that we did later on. I think that the file system was not. It was FSCKing itself to craziness, if I'm remembering.
Yep, you're right. It's Veritas. That was the other, because Courtney, you're exactly right. And the part of what made the early 2000s an exciting time to be at Sun is that a bunch of us had kind of looked at the state of the world with dissatisfaction. And one of the other things that was very dissatisfying, and you're right to latch onto it, is that FSCK time. And that's when Jeff was like, we've got to take a from scratch approach. Jeff Bonwick was like, we got to take file systems from scratch. And that was the origin of ZFS.
I think that was Shaheen, but I did have a question also for you, Shaheen. You were there at Sun, so you came in with the Cray acquisition there. At the same time, that was around the Thinking Machines acquisition. Do you have any background on that? I was always curious.
No, well, when we were at Cray, Thinking Machines was kind of a competition, right? And our joke was that they had the best food in the computer industry. This was before Google got the same, the mantle. But they were obviously hot, and they were very, very smart people. So the Thinking Machine acquisition, Tom would remember it better, had happened before the Cray acquisition. And that's how Greg Papadopoulos came to the company and went on to be the CTO.
I was long gone from Sun by then, I think. So.
Oh, were you? Okay.
And that's the origin story of Greg passing on Oxide. The great.
Oh, how misguided.
No, God bless Greg. Greg also funded Fishworks, so I can't. But he also did pass on Oxide. So, there you go. Mixed bag.
They were certainly another example, I think, to Brian's earlier point of, extremely smart people, but from a business standpoint, just kind of all over the place.
Totally all over the place.
And that was the reputation. Yeah.
Well, if we can go back and talk about the people aspect of Seymour Cray. I mean, it seems like he's the kind of guy you would love to work for, and he'd be impossible to work with.
Yeah, that's interesting. Shaheen, did you have exposure to Cray at Cray, or was he in Chippewa Falls?
No, he actually was already Cray Computer by the time the acquisition of FPS happened. And he was doing his gallium arsenide in Colorado Springs, was it?
Yeah, Colorado Springs,
yeah. And of course, when he passed, it was giant news at Cray. And everybody was like, because, he actually stayed in the hospital for like a week before he passed away.
Right.
And everybody was saying, if anybody can pull through, he will, because he has that kind of a will. But he was surrounded by a couple of people who really made his stuff work. Like Les Davis, which is like one of the unsung heroes of supercomputing. And there were like 2 or 3 others around him. If you went to Chippewa Falls in that era, it was just an incredible place. Extremely smart people, like doing nothing else but building this stuff. And I think those guys were the ones who made Seymour's designs work.
Yeah, it's so interesting. So actually, Shaheen, if you read Superman, I'd be curious to get your take on this. He talks about Les Davis a lot, and he does, I think, leave you with the impression that Davis is every bit as important to these machines as Cray is. And in fact, they were a very.
Absolutely.
It feels like they had a good. Like they kind of needed one another. I feel like they seem to have done their best work when they were working together.
Definitely. And now Les stayed with Cray Research. Of course, another joke was that Cray Research builds computers and Cray Computer does research.
Yeah, that's right. Well, and actually, it's funny that I didn't realize this until reading the book, that the origin of Cray Research was deliberately wanting to get out from under the thumb of what he viewed as kind of short-term machines at CDC and kind of derivative machines at CDC, and doing machines that were more speculative. And that's why they deliberately put research in the name when he kind of defected from. But yeah, that's a funny. It certainly seems apt, Shaheen.
That's right. Actually, I was at IBM when that happened, and when I came to, within IBM, there were a whole bunch of people who were faulting IBM management for passing on Cray, because Cray had approached them to say, "Will you fund me? Will you fund me to do this?" And they said no. So he'd gone and done his own thing.
Yeah, interesting. And so, what was it like? Because I did not realize that the business systems division inside of Cray had come from an acquisition. Of course, that makes a lot of sense. Because I felt like that machine was so commercially minded. It had such a good idea of who the customer was. It must have been tough to. That must have been a real juxtaposition certainly with Cray historically. It was.
Yeah, the motivation for that, from what I understand, is that the commercial people. The story was like people like Walmart were coming to Cray saying, "We'd like a commercial supercomputer." Now, the Cray supercomputers, they were running Unix, sorry. And in fact, I think outside of Sun, Cray was the only other vendor that actually owned their copy of Unix, that bought it. And Unicos was a very nicely implemented Unix at the time, including like hierarchical storage management native to the OS. And they've done all of that, but it was real memory. There was no virtual memory. It was 64-bit addressable. It was a pain in the neck to port database packages on it.
Right.
They had like Empress on it. They'd managed to do that. But forget about, I think they were working on Ingress. But anyway, so they basically said, okay, we're going to go build a commercial supercomputer, and buying Floating Point System was an acceleration of that because it was already running Spark Solaris. We had all the catalog. Let's go take that and then build like a 64-way system for it. And that was the Cray Super Server 6400, the initial 64-way system. And then Starfire, codename Crossfire, was the UltraSpark version of it that actually was launched under Sun.
Right. But that would have been developed under, because certainly it feels like it launched very shortly after the acquisition. It feels like that thing was ready to go.
Well, actually, David Yen's group and Clark's group were already working very nicely together, even with the XD bus that came from Xerox. Before even the x86, the CS6400 was already a joint development with Sun.
Right. Yeah. Right. Yeah. The software group did have a bunch of dragons. The XD bus was for the Scorpions and Dragons, the Sun 4Ds, which I've got very fond memories of. Newton, Pod, and all those that we had in our lab. Adam, I don't know if did you ever work on the Sun 4Ds at all?
I never worked on them. I think I had to test out some mods on them, but never did anything serious.
Part of my problem, I get too much emotional attachment to these kind of machines. It's part of my problem. But I definitely remember those machines fondly.
All these pets.
Pretty much, exactly. Well, and those are the ones that Roger would always have me power cycle those machines. He was calling if Roger was calling me in the middle of the night to go power cycle a machine, it was definitely a Dragon. It was a Sun 4D. So Shaheen, that must have been. Certainly that felt like, so from your perspective as well, that just felt like an incredible, I would say merger is almost too saccharine a word. It's kind of confluence of what the future of commercial compute should be, and it was just a fun time. It just felt very explosive.
Oh, it was huge, and it was emotionally extremely strong for everybody. When Starfire was launched, people were like crying.
Yeah, interesting.
And for all the FPS people who'd slugged it for so many years, it was like coming home. It was like we finally managed to do this. It was a big deal. A lot of sweat and tears and emotion into that. definitely.
That's amazing, because certainly I can tell you from the software side, it felt great, because like this is such a vindication for the software vision, because the software vision was really around. I mean, I came to Sun because Sun believed I felt more fervently in SMP than any other company. Maybe SGI, except that SGI was the other one that also believed heavily in SMP. So it was a real confluence of visions in that regard.
It truly was, yes. And Jan Peter gets a lot of credit for that, because he was running Solaris at the time.
I'll throw out a little strange history thing too. I don't know if everyone knows, but SGI and Sun were almost one company at a point in time.
Okay, you got to tell me that story. I actually don't know that story. When was that?
So in the very, very, very early days, there was actually a meeting at Ed McNeely's apartment in Mountain View, where the founders all got together. And my understanding from folks that were there was that it was no one could decide who was going to be CEO, so it never happened. But
so this is McCracken and McNeely getting together.
Well, what I heard was that Andy and Jim Clark didn't really like each other very much.
Yeah. No, it was Jim and yeah, and it would have been interesting. The other interesting thing was the early SGI boxes were licensed Sun boards from Stanford. So there was a very incestuous relationship, obviously, between the companies. But
I didn't know that.
It was interesting that. Yeah, the early terminals were inside an early terminal was actually Andy Beckelsstein designed Sun board. Sun as in the Stanford boards. But the companies were really close in the early days, and it's just amusing that history between the two of them.
Yeah, and I feel that I came out at probably the height of the rivalry between the two companies. So I joined Sun in 1996, and I feel like in many ways, Gerald, I would love to get your perspective on it, but the acquisition of Cray by SGI is kind of the height of SGI hubris. Do you disagree?
It was for me, man. You should have seen how red I was in that meeting with the execs trying to stop the sale. But no, there was a point just around then too, internally at Silicon Graphics, that got up my nose. We had a corporate slide deck presentation. In our wonderful showcase, the 3D PowerPoint thing that would, but the second slide was talked about how we're half the revenue of Sun but twice the market valuation, and therefore the customer is meant to take away something about how good we are. And I thought that's the most disgusting slide to show customers. Like you're overhyped as a company, But so many sales guys would take this stupid corporate slide and stick it in the slide decks. That particularly got up my nose. I made sure that any presentation I was in, we did not use that slide. But no, I think you're right. The Cray sale to me just killed it, and that was when I turned around and started to look at leaving Silicon Graphics.
Yeah, I really felt that before, it was either Shaheen or Tom. I think it was Tom that cruelly mentioned Rocket Rick Beluzzo and the movement to Windows NT, which was such a tragedy to watch, because it felt like, and that to me felt like it was happening broadly in the industry. I mean, that to me was what kept me certainly at Sun, was the belief in system software and not mortgaging our future to Microsoft.
No, that was a disaster. That was just after my time, but that was then watching it as an outsider. It was just like, what the hell is Silicon Graphics doing? It's sort of committing suicide. But while I was there, still, we had the Origin series come out to replace the Challenger, which was a NUMA machine. But it's a sort of a funny little anecdote with, the higher NUMA machine. But it was like, as John Massey described it, the most wonderfully scalable NUMA architecture packaged in the most unscalable packaging. The first generation packaging was just terrible, but there's a history for why, because we were targeting the supercomputer market. So we made the economics only worked if you were buying 100 CPUs. If you wanted to buy a 16 CPU box, it didn't work. So that was sort of the second major failure after the sale of Cray.
Interesting.
The transition to Origin. But the day that we announced all the stuff, we announced the low-end O2 workstation, and their marketing message was all about being not NUMA. It was all about being NUMA, shared memory for the GPU and the thing, and UMA, uniform memory access. So how shared memory is great for your GPU, and that was literally their marketing message. And we came out with the Origin at the same time, and our message was NUMA is good. So you had two the low end and the high end of the company
fighting with one another.
marketing Uma versus Numa, and I'm, why did you not? Didn't they even coordinate with each other the marketing message? And that was just another final straw. I mean, these things were then piling up on top of each other. It's like, this is not a good thing for a company.
Yeah, it would have been, I mean, you mentioned the Challenger, because I remember, Sheen, do you remember the ads that SGI had very good ads that they were running very briefly about why I think Netscape was running the Challenger, and they had this "Because They Rock" ad with the guy with the Nerf gun, and I remember thinking like, man, it's good copy, and it felt like that was, I think it felt like SGI having a real strategic window, but then. Well,
oh, they were great at that. Daryl would remember this ad about, I think it was like the 777 Boeing.
Oh yeah,
and they had like a big photo of this giant plane, and underneath it was like this tiny box, and it says, "Here's like the greatest airplane in the world, and here's the box it came in."
Yeah, that was great. It was interesting. The marketing was not. We were not connected to corporate marketing at all on the commercial service side, and we were sort of this big disconnect. And that sort of got solved one day. Corporate marketing, this an amazing ad, which was just a field of sheep. And so when we was just starting to get into early web servers, and it's hard to remember back when computers had trouble running web servers, but the early work with the low end servers, just running web servers in racks, and we were doing quite good in that market. But this ad was tremendous. It was a field of sheep trying to get through a gate, and the message was something like, "What do you? The worst thing that happens is if you build a popular website," and it was just a really good visual ad. Anyhow, that started a good discussion where we got closer to corporate marketing. We're doing more stuff with them.
Yeah. So someone mentioned the T3D and T3E, and that was another big era at Cray, because clearly MPPs were coming, and of course Cray was very loath to do clusters, because clusters were like not going to work at all, but MPPs would. So the whole interconnect and space sharing instead of time sharing and all that OS, and they kind of got the mock microkernel and put that into the Unicos, and of course they needed a CPU, and they ended up going with Alpha, and that was another big. I think they installed a few T3Ds, and it became sort of the company, and I think they lost the IP with that when SGI acquired the company. And when they released Cray again, they basically released it pretty bare bones. They didn't have a whole lot of IP when that happened.
So that's when it got acquired by Terra from SGI?
That is correct. I think a few years after SGI acquired Cray, it decided that it needed to spin it out again. It kept all the juicy stuff, like the hierarchical storage management stuff. It was, I forget what it's called now, DMF, Data Migration Facility. They kept that. They kept all the patents. They kept all the everything, but they basically let go of all the vector systems and maybe the.
It was at this moment that the Twitter space ended suddenly. Brian was disconnected, and for some reason, that brought the Twitter space down. We restarted the Twitter space a few seconds later. We're missing a little bit of the conversation, but only a few seconds.
Stories to tell, because obviously he was very intimately involved, or knew that the acquisition was happening.
He was very intimately involved, and we were in violent agreements, because from from the Sun side, from the Cray side, I was surprised. The whole SGI Cray deal was a Twilight Zone deal. It made no sense.
It made perfect sense. It made beautiful sense. It just made no sense for them to do.
Yeah, that's right.
It was glorious. And I remember, just so many E10K stories. I remember do you remember Boo.com?
I do not know.
Okay, Boo.com was maybe the first. Adam, do you remember Boo.com?
They were like a online market, maybe like eBay or something.
Yeah, right? You're so close. Yeah, streetwear. They were going to sell streetwear and it was going to be this very kind of rich internet experience. The problem is that everyone was still on like 2400 baud modems, so it was like a little early. And so they were a super early flame out. The Benetton family founded them, and they flamed out in like early 2000. But Shaheen, they had an E10K. They had an E10K with a single CPU board in it. And it's like, oh man, God, the sales guy. And actually, So then the CTO of Boo, when he realized that Benetton was getting cold feet and the family was going to pull out, they pull out. He starts his own LLC to buy the E10K from them, and then he sold it into the gray market when it was. I mean, he made a bunch of money he made a bunch of money flipping E10Ks. I don't know how many people have done that in history, but he definitely did.
Well, there was a time when he could do that because we were production limited for pretty much the entire history when I was there. And,
yeah, I mean, I remember. I mean, what they told us is that they were having to ramp up a third shift to get that thing. I mean, they just like the manufacturer. They were manufacturing it. It was a manufacturing bottleneck ultimately.
It was, and then we started one in Newark, and in addition to Hillsboro, Oregon. So we had like 2 manufacturing sites, and then eventually also in Scotland. So it was like a really popular system. I think at the end of the day, it was something like over 5,000 units sold around the world.
Man, that's amazing. That is amazing. And there were, and I mean, you remember Jared and Enron had a bunch of them, Adam. I mean,
sure, yeah.
Which was great. The Shaheen, did you know Jared Jensen at Enron? Did you talk to him at all?
No. I basically, between Clark and I, we split the geo. So he was doing US and I was doing international because he didn't like traveling long distances.
Well, then, so yeah, so Enron was, I mean, obviously Enron, a crooked company that exploited California's power market, but also had some really sharp IT folks. And Jared was an IT at Enron with a bunch of 64Ks or E10Ks and fully racked out E10Ks. And he was in our platinum beta program, and there was this great moment where he has got this Southern accent, and he definitely enjoys laying it on thick before people know how. I mean, he's a super sharp guy, and before people kind of know that. I mean, Adam, don't you feel that he turns up the accent too?
Oh yeah, he starts fixing to do lots of things.
He's fixing to do everything, and I don't know about y'all, but and everyone's thinking like, we're all in IT because we are a Big Sun customer, but who's this yokel? Like, he doesn't have any. And finally, they go around the room being like, what are people actually running? It's like, well, we got 5, 6 E10Ks, but I'm fixing to get 2 more. And this is at a time when people are like, I'm not allowed to look at an E10K, and this guy has got 6 of them. But it was definitely it was a great machine, honestly. You all, and she didn't talk about the interconnect. I mean, that was a very impressive interconnect on the E10K.
Yeah, so the CS6400 was 4 parallel buses that did address and data, and that was the XD bus that could do 1 bus, 2 buses, and 4. The 1 was the Spark Server 1000. The 2 was like Spark Center 2000, I think, if I'm not mistaken.
Yep, that's right. Yeah.
And then the 4 was the CS6400. By the time it got to the Ultra Spark, they could do point-to-point communication. So Starfire had a crossbar, 16-way, 16 by 16 crossbar that connected every board to every other board for data, but then addresses were like a round the the single wire sort of a thing. And then with the one after that, the Sunfire 15K or 20K, whatever it was, the address was also crossbar, so point to point. Now the point to point connection also allowed us to partition the machine. So we had hardware partitioning, because you could isolate a subset of boards and boot a copy of Solaris on it separately. And our joke was E10K was multiple versions of Solaris, otherwise known as MVS.
Yeah, interesting. And so because the E10K, because it did perform well, I got to believe that there were Cray customers who were attracted to the economics of running MPI on an E10K. Was that? I assume that there were HPC customers for the E10K. Certainly, I dealt with a couple.
We certainly did. I think, if I'm not mistaken, something like 10-15% of the installed base were actual HPC, and those were bigger memory systems, and it really was more of a memory thing than a CPU thing, if I remember correctly. And of course, UltraSpark was decent. It had the combined multiply add instruction. But it wasn't exactly a supercomputer.
So, it was not exactly a supercomputer. I was going to say, you don't feel like you need to be too.
No, I know. Yeah. Actually, speaking of that, back to Seymour, one of the uses obviously was climate modeling, weather forecasting. But the spooks were using Cray supercomputers because he had a bit count, pop count instruction. And that instruction was specifically put in to facilitate whatever it is that they do.
Okay, I've always wondered that because I know the legend of POPC, the Spark instruction, but what is it that the spooks could do with that?
Presumably, if he can quickly count the number of bits in a word that are flipped, is a useful thing because he can do logical operations like 64 at a time. Kind of a thing. That's as close as I've been able to understand it.
Adam, I've always had the same kind of question. I'm like, I get that like POPC is used to like fund civil wars in El Salvador or something. Like POPC, I get it. It's used for espionage. I don't understand.
Right. That my understanding was that it could enable untold evil, and that don't worry about it because it's now emulated. Right.
And I think we ultimately did end up adding POPC. They did end up adding POPC to Spark, I believe.
I believe so too.
It was a big Spook special.
Yeah, Spark has POPC, but it trapped for every version of Spark that I worked with.
Oh, interesting.
Yeah.
And the spooks never complained, as far as Adam knows.
As far as I know, they weren't calling me.
Well, they wouldn't. They just follow you.
Daryl, do you know the pop count stuff? You might know.
No, I don't. Sorry.
I know it's crypto related, right? It's about computing Hamming distance.
They're right. I think
it's generically for a lot of things. It's not specifically for just crypto, right? But anytime you're dealing with bit sets or things like Hamming distance, or there's a lot of uses that don't involve overthrowing small countries.
So you say.
So the other question, so Shaheen, I guess you guys came to Cray, said after Cray himself was at Cray Computer. So this is also, I am now dying to know more about Steve Chen and supercomputing systems, just because every dimension of that company is just so out of sight.
So Steve Chen, was the guy who really made Cray YMP happen. Cray XMP maybe even. Because Cray 1 was done by Seymour. I think Cray XMP, Steve Chen was like the chief engineer on. And
That's
then
right,
Cray YMP, if I'm not mistaken. And then I think after that, he branched out and IBM decided to fund him because they'd missed out on Seymour. And he went to Eau Claire, Wisconsin, not Chippewa, a little bit farther out, and set up shop. I remember at the time, the idea was that he was, in fact, taking too many risks on too many dimensions, unlike Seymour.
Yes.
And that he was pushing it on too many fronts, and it was like a really challenging thing. And of course, in fact, after a while, it didn't work out. Now, he ended up at Sequent for a while. And then he had another, Tombu, I think, was a system company. Because I talked to him when I was at Sun, and they were doing some startup that Greg wanted me to look at. And I actually had breakfast with him a few years ago because he's in the area and he's still doing some cloud-oriented thing. But he's obviously another Hall of Famer in this world.
Yeah, and it'd be really interesting to talk with him and get his perspective on it all. Because that's certainly the Murray in the Supermen definitely. I mean, Adam, that's your 78 layer board, and it definitely feels like they are just pushing things too hard in too many directions. And then they're also rewriting all of software from scratch, which is not a recipe for shipping on time. There is, and Shahina, there's a line that actually, Adam, may I do an out loud reading from Superman? Do you mind?
No, by all means, I encourage it. Yeah.
All right. So this is after.
Do you mind if I throw in one comment before we get too far ahead? I just wanted to add that when you're encrypting something, it looks indistinguishable from random noise. And when you decrypt it, you are almost always going to get a significant entropy drop. So almost no matter what the encryption method is or whatever encryption you're breaking, you've won because you did a pop count over the output and said, oh, look, the entropy has changed dramatically from the entropy before. I actually found the right key and now I'm happy. So if I'm wasting a lot of cycles on pop count, I'm going to be able to grade a lot fewer keys that I've attempted pretty much no matter what I'm trying to decrypt.
Well, there's your answer, Fishbulb.
So pop count is really great for the like, haha, everything just got better and the entropy dropped, and now all your secrets belong to us.
Way cool.
There you go. Well, that makes sense.
And you got to check a lot.
Right, exactly. Right, by the way, we're going to be checking that a lot. So thank you very much, Aaron. That is very, there you go. That answers that question. So Adam, this is after, so as with all these companies, supercomputing systems fails because they are all locked out of their offices. Was it actually a frigid morning in January? I mean, it sounds like it was a morning in January. It's described as frigid, it probably was. Anyway, so 2 months later, I'm reading from the book now, one of the company's engineers was driving the backwoods of Wisconsin, miles from Eau Claire, when he spotted a familiar object, the SS-1. There, on the grounds of a small farm nestled in the northern Wisconsin forest, sat the machine's outer frame. He slammed on the brakes, veered the car to the side of the road, and jumped out. Examining the machine's skin, he spotted boxes containing more parts from the SS-1. He gently ran his hand over the parts. His heart sank. Whatever hope they'd had for resurrecting the machine was now gone. He knew there was no turning back. The SS-1 had been sold for scrap. Which is just like, oh man. But I think it also goes to, I think Shaheen, you were mentioning earlier that the folks at Floating Point Systems feeling like that sense of exhilaration to watch their machine actually come all the way to market and come into like a market that was ready for it and hitting everything right. And how, I mean, you can see why people were, in tears when their machine actually like lands, because that's the alternative. The alternative is you're driving a backcountry road and your machine is like on a farm somewhere about to be turned into, a tractor.
Oh, heartbreaking! Absolutely heartbreaking.
Heartbreaking. And just like the way it's described, you like running his hands over the parts. It's like, oh man. I'm right there with him. Anyway.
Yeah, totally.
Well, we've been wanting to keep these to about an hour. I know we went over here. Adam, my apologies to your toddler, who I know gets. I keep waiting for him to like join his space under his own account and tell you to like, feed him dinner. But this is great. Shaheen, Daryl, thank you so much. And everyone, Courtney, thank you. Jason, Simeon, everyone, thank you very much. That was a lot of fun and just incredible for the folks that actually lived this history to be able to share it with us.
Can I tell one last anecdote?
Do it.
I was thinking live the machine that won, along with the people who won the Gordon Bell Price Performance Prize in 2000, called Bunyip, while the people who actually put it together and were running the software were elsewhere. It was in the computer science department at the ANU in Canberra, and it was 384 Pentium 3 550 processors. And this is kind of supercomputing like working an angle rather than supercomputing like massive engineering effort. There was this Epoch's dual processor slot 1 motherboards, which were going really cheap. And there were these Pentium 3 550s, which were at a really good price point for single precision SSE. And so 32-bit floating point. And they managed to convince the judges that this problem was genuine. And I've got some issues with that. But the particulars of this story is that while this thing was running its, big benchmark, it's actually 192 nodes, and it's got a fancy network architecture, which turned out to be irrelevant. But machines kept blowing up. The capacitors would actually go pop off the board. And I was running these machines up to the local vendor who had collaborated with us and who thought that somehow they were involved in supercomputing because they just had a big supply of these Epoch's dual processor boards. Turned out in the end, the things that were dying were the Pentium 3 550s, which were based on the old discrete cache, which had the larger geometry processor and were drawing a heap more current, and the Pentium 3 550s that were all on copper mine with the 256K on die cache and drawing much less power. They weren't actually degrading the capacitors on these boards as fast because it was during the capacitor plague. And so basically we just had this cusp where half of the machine was bought with old Pentium 3s and half of it was bought with new Pentium 3s, and half of it just broke constantly during this mammoth run to, produce these results that apparently meant that the ANU Computer Science Department was heralding a new age of supercomputing, but it was really Virginia Tech, only on a smaller scale. If you remember Virginia Tech.
There you go. Yeah, right. See, the consequences of I love the capacitor plague. I want to get more details on the capacitor plague.
But Virginia Tech, well, it was a stolen recipe from a Japanese electrolytic capacitor manufacturer, turned up in, I guess, Taiwanese capacitor manufacturer at that point. I don't think China was kind of there yet. But it had a missing component, which actually was part of the electrolyte that stopped it from developing gas. And so these things, when you had large ripple currents through them, they would get hot, and then the electrolyte would start to outgas. And then those bulges that you see in the top of old electrolytic capacitors, that's the sign that they want to go gaboom. And these ones would blow themselves all the way across the case and sort of land on the yeah. So it was very comical. Except I was running up and down and basically just swapping pieces of the organs of this machine, trying to keep enough of it running that they could do this thing. But where was I going with all of this? Virginia Tech. You remember they had a whole bunch of G5 rack.
Apple racks, right?
Systems. Yeah, Apple G5.
Yeah, Apple absolutely quashed that. They wouldn't let anybody else do it.
That's right, because it didn't have ECC. Someone worked out that basically it was just a Linpack demo machine, and they had just like some incredibly anemic file server at the core of it. So in terms of its ability to do real work, they just took it apart and replaced it with ECC G5 rack systems later on, and that was what they actually moved into production with. So it was just basically, here's $10 million, get us on the top 500, and they got to number 3, but it didn't really mean very much. Anyway, yeah, Bunyip was a bit like that. Anyway. There
you go. All right. Well, exploding computers is a good way to end it as any. All right. Well, thanks again, everyone. Yeah.
Now, just speaking of exploding computers and racks left in the middle of cornfields, how's the oxide rack bring up going?
Exactly. There you go. Well, we'll tell you next time. No, we have actually blown none of them up exactly. We did have we've had some excitement, no fires, but it's going well. We're having fun. So we can talk more about that next time. But no bad caps, and unfortunately, not a victim of the capacitor plague, the great capacitor plague. So. All right. Thanks, everybody. We'll talk to you next week.
Thank you, guys. Thanks a lot. A lot of fun.
You bet. Bye.
Yeah, thanks for joining, guys. Thank you.